Hello and welcome everyone, Tiberius here with part 2 of our series creating Burp Suite extensions using the new Montoya API. If you somehow missed part 1, no worries, you can find a link in the video description. I highly recommend checking it out before continuing. In the first video we set up our development environment and built a simple extension that slapped a fresh new header onto outgoing requests. Today we're going to tidy up our extension code by separating the header functionality into a different file. We'll also change how the header value is calculated and store it so it doesn't get lost when the extension or even Burp Suite itself is restarted. As always, if you think up a cool idea for the extension, please share it in the comments and I'll do my best to code up the most popular ones in future videos. If you enjoy the content, please consider giving the video a like and of course subscribing to the channel.
As cyber threats grow, so does the need for skilled professionals. TCM security certifications are here to elevate your skills to meet these challenges. Our courses are tailored to give you an edge with practical scenario-based exams. Step into the world of advanced cybersecurity at certifications.tcm-sec.com and make your mark.
To get started, ensure you've upgraded Burp to at least version 2023.10.2.4. which is the latest available on Kali as of this video. This will allow you to access the Montoya API features we'll be using this episode. In the last video, we created an extension in a single file called MyFirstExtension. While a single file is technically fine for small extensions, it's better to organize your code as it grows. Let's begin by moving the HTTP header functionality into a separate file. Open up Source and right-click on the Java folder. Create a new Java class called MyFirstHTTPHandler. In this class, specify that we want to implement the HTTP handler interface. Make sure to select the Montoya version of the interface when prompted, which will add the correct import statement for you. You'll notice a red error line, and that's because we haven't implemented all the methods of the interface yet. If you recall, last time we right-clicked and used the Show Context Actions helper to add these. This time, since we already have the code for them, we can simply cut and paste this code from the MyFirstExtension class. Now that our MyFirstHTTPHandler class is valid, we need to remove the implements HTTP handler from the MyFirstExtension class definition. You might notice that with this removed, the associated import statement has turned grey. This shows us that it is currently not being used by the class. Nothing bad will happen if we leave the statement in, but we might as well remove it since we don't plan on using it here. Also, you should see an error with the registration of the HTTP handler, which is because we are trying to register an instance of the current class using the this keyword. Since the class no longer implements HTTP handler, this won't work. Instead, we need to create a new instance of the MyFirstHTTPHandler class. Create a new variable of type MyFirstHTTPHandler called handler. Then use the new keyword followed by the class name with a pair of parentheses after it. Replace the this keyword in the register HTTP handler method call with the handler variable. To create an instance of a class, we need to define a constructor. Let's create a simple constructor for the MyFirstHTTPHandler class. This constructor is minimal, but is all we need for now. After this, recompile the extension and reload it in Burp to ensure everything still works. Now, let's add some additional functionality to our handler. Instead of adding a header with the same value to each request, we'll extract data from the previous response to calculate the value for the next request. We'll use the age and date headers, concatenate them, and hash them using SHA-256 to generate the next request header value. In our MyFirstHTTP handler class, create a string instance variable called hash to keep track of the latest value. This will be accessible by every method in an instance of the class. Instance variables are usually defined right above the constructor. Generally, instance variables are given the private keyword, meaning they cannot be accessed by other classes. While we don't have to give the variable a value, by doing so, we ensure that it will have one when an instance of the class is created. Now we can modify the handle HTTP response received method, which we previously left alone. Since we aren't modifying the response, we can keep the return null statement as is. Instead, we're just going to use this method to extract the age and date header values, calculate the hash, and store it in the instance variable. First, let's create a local string variable input to store the header values before we hash them. We want to set this variable to an empty string, so it has at least some value we can hash, just in case a response doesn't have the age and date headers. Next, we want to check if the age header exists within the response, and append it to the input string if it does. The method argument, HTTP response received, contains information about the response, and we can use its hasHeader method to check if a specific header exists. To append to a string variable, we can use the += operator, and to get the header value, we can use the aptly named headerValue method. We can copy this block of code and change both instances of age to date, extracting the date header value. To handle the hash calculation, create a SHA-256 instance of the MessageDigest class. A red error line appears because the getInstance method can potentially fail if the string we gave it does not match a known hashing algorithm. To prevent our code from not functioning correctly, or even crashing the program, Java needs us to put in some error catching code. Right-click the error and select Surround with Try Catch. A try catch is a set of code blocks. Within the try curly braces, we put all the code which could potentially fail. Then, the catch block parentheses contains an exception instance, followed by a set of curly braces containing code which we want to run if a failure occurs. In this case, the exception which may occur is a no such algorithm exception. Many exceptions in Java are named descriptively, which helps developers understand what they are and why they might occur. Note that a try-catch may have multiple catch blocks, one for each possible exception. Alternatively, you can technically create a catch-all block of sorts by changing the exception class to just exception. However, this is considered bad practice and is not recommended. For now, we can leave the catch block code alone. Since the SHA-256 algorithm will almost certainly exist in Java for many years to come, there is a near zero chance of the no such algorithm exception being thrown unless you have mistyped the algorithm. Since the code we want to write is all related to the message digest, we can put it all in the try block. We need to update the digest with the input data. We can see from the helper menu that all 4 possible update methods take some form of byte input. This one takes a simple byte array, as denoted by the square brackets next to the type. Luckily, string objects have a getBytes method we can use to generate a byte array of the string character values. Note that this method requires us to provide a char set. We can assume everything will be in UTF-8. Note that there is now a red error line and a yellow warning line. The error occurs for the same reason it did when we provided the SHA-256 string. It's possible that the UTF-8 value we gave isn't a real char set. We could add another catch block for this exception, but there's a nicer way to solve this. If we hover over the yellow warning, IntelliJ will tell us that instead of providing a string directly, we can use the standard charsets class. If we click replace with standard charsets.utf_8, we can see that both the warning and error message disappear. We can now generate the hash or digest by calling the digest method. Note that this method returns a byte array. The standard way to display hashes is with a hex string, i.e. converting each byte to hexadecimal and concatenating them together. Luckily, there is a standard class in Java called hexFormat, which allows us to easily generate hex strings from a byte array. We want to store this hex string in the hash variable we created. Since we're in a class method, we can use the this keyword to reference the current instance of the class, then a period, followed by hash to reference the hash variable. Now an equals sign to assign something to this variable. Finally, we can reference the hexFormat class, add a period, and choose the of method with the format hex method after it. The of method just sets up the formatter so it will produce a string comprised of all lowercase characters and no delimiter. The format hex method takes a byte array as an argument. Within the parentheses, use the digest variable again and call the digest method so it returns the required byte array. If you're ever wondering what various class methods do, you can find detailed information in the official Java documentation. Simply search for the class name, e.g. hexFormat, or even the method name, and choose the matching result. There should be a detailed description of the class, common code excerpts, and a full list of the methods. Clicking on one of the methods will bring you to a full description of it. Now, let's change the handle HTTP request to be sent method to use the calculated hash instead of the static value. To avoid adding the header if the hash is empty, use an if statement and the isEmpty method. Negate it using an exclamation point to make sure the header will only be added if the string is not empty. Let's change the header name to x-hash and the value to this.hash. Finally, note that there is now a red error line at the end of the method. If we hover over this, we see that IntelliJ says there is a missing return statement. Even though we have a return statement here, it will only be executed if the hash value is not empty. We need a return statement for when this is not the case. Luckily, we can simply add a return null after the if statement closes. Although this might look like we're returning a value twice, we are not. Once any return statement is reached, none of the remaining code in the method is executed. Keep this in mind when developing code. Let's rebuild the extension and reload it in Burp Suite. We'll visit example.com again, then we will refresh the page. Back in Burp's logger, we can see the first request did not have the additional header, but the second request did, as will every subsequent request. There's one issue left. When the extension is reloaded or Burp is restarted, the calculated hash is lost. To address this, let's add the ability to automatically save and restore the most recent hash value. Create a new Java class called UnloadingHandler and implement the extension UnloadingHandler interface. As we've done before, get IntelliJ to resolve the error by implementing the missing method. In the UnloadingHandler class, we'll save the latest hash value when the extension is unloaded. To do this, it will need access to the MontoyaAPI and the myFirstHTTP handler instance. Define instance variables to store these. Create a constructor that takes both instances as arguments. Note that although the instance variables have the same names as the arguments in the constructor, they are separate entities. This will become apparent within the constructor itself, as we need to assign the API argument to the API instance variable and do the same for the handler. Although it may look like we're assigning things to themselves, we can click on the API variable and see that the argument is highlighted, showing it is the same. If we click on the this.api, we see that the instance variable is highlighted instead. If this is too confusing, you can easily rename the argument. Don't do this manually, however, as it could break your code. If you ever want to rename something, use IntelliJ's rename feature. Right-click the thing you want to rename, choose Refactor and then Rename. Now we can type whatever we want the new name to be, and IntelliJ will automatically update all of our code wherever the old name was referenced. In the extension unloaded method, use the MontoyaAPI to save the hash value. Remember to use the this keyword when referencing instance variables here. We'll first reference the API, then choose the persistence method, then preferences, and finally setString, since the hash is a string value. We need to provide two strings, one being a preference name we want to use when saving, and the other being the actual saved value. Let's use hash for the name, and then we can reference the handler instance variable to get the hash value. However, the hash variable isn't there. If we look at the myFirstHTTP handler class, we can see why. We originally set the hash instance variable to private. There are two solutions we could implement here. The first is to just make the variable public, which would mean our UnloadingHandler class could access it. While this is the simplest solution, making instance variables public should be avoided in most cases. Instead, it is best practice to create a public method in the class which returns the private instance variable. This effectively makes it impossible for other classes to change the variable's value directly, which is good because we only want the hash to be generated from the headers. These methods are known as getters, and they are very simple to implement. In the myFirstHTTP handler class, add the following code below the constructor. Public makes the method accessible to other classes, string is the type which the method returns, and getHash is just the name of the method. The method does not need any arguments, and inside the curly braces, we just need to return the hash instance variable. Back in the unloading handler, we can complete our code by referencing this method. Now all we need to do is register our new handler in the myFirstExtension class's initialize method. Remember that we need to provide our new unloading handler instance with the MontoyaAPI and myFirstHTTP handler instances. Now when the extension is unloaded, it will save the hash value. To restore it when the extension is loaded, modify the initialize method to check for the existence of the hash value in the extension preferences. First, let's create a local string variable called hash and set it to an empty string. Next, we need an if statement where we access the API, persistence, preferences, and then the string keys method, which returns a set of all the key names for string values. We can then use the contains method to check if the hash key is present. If it is, we can set the hash variable to the value by using the getString method. When creating a new MyFirstHTTP handler instance, pass the hash variable to the constructor. An error occurs because the MyFirstHTTP handler class isn't expecting anything to be passed to the constructor, so let's fix that. In the class, add a string argument to the constructor. Then, inside the constructor, set the instance variable to this value. Rebuild the extension and reload it in Burp. Send a couple of new requests, noting that the extension is adding headers. Next, restart Burp and send another request. The extension has used the hash value it calculated prior to the restart, and has added it to this first request. In the next video, we'll add more features to our extension, exploring other parts of the Montoya API. As I mentioned at the start, if you have any requests for specific features, please let me know in the comments. I'll upload the code from this video to GitHub and provide all the important links in the video description. That's all for now. If you enjoyed the video and found it informative, please consider giving it a like, subscribing to the channel, and I'll see you next time.